first advanced meeting. We're going to be going over how to do the 3 problems from this week's problem set. And I'll start with the first problem. All right, so basically this problem is called Lemonade Stand in China. And if you haven't read the problem already, you're basically given this grid of numbers. And then you're asked to find the sum of the 3 by 3 squared with the largest sum. So in this case, I've copied in the sample case where the 3 by 3 squared with the largest sum is this one right here. And those numbers sum to 31. So then you would output 31. So basically to solve this problem, since the constraints are pretty small, like we only have 100 rows and columns, you can basically loop through every point and treat that point as the center of the 3 by 3 square. So if we're on a given cell as the center one, in order to loop through this 3 by 3 square, we would loop through we'll loop through these 3 rows, and then for each of these 3 rows, we will loop through these 3 columns. So a good way to implement that would be like you would loop through the delta R. So the current R, the current like row and column, are given by like this current cell's row and column. And then the delta row would be like -1, 0, and 1. And then you also loop through the delta column, which would be -1, 0, 1. So if you have that nested loop of those deltas, we would eventually loop over all 9 of these cells in this 3 by 3 square. So we would then do that for all of the cells in the matrix. But one slight like implementation complication is what happens if you're treating an edge cell or a corner cell as the center of 3 by 3, because then you would be looping into out of bounds like territory here, and then you would get an error. So this problem is actually pretty convenient for us because all the values in the matrix are positive, which means that it will never be optimal to make the center of your 3 by 3 square on the edge or corner, because you can always just make it better by moving towards the center, right? So you can include more values. So basically all we need to do is loop over all the values, like loop over all the cells that are not on an edge, and then treat that as one of the centers, and then compute 3 by 3 square, and then keep a running maximum sum, and then you update that at every cell in the matrix. So now I'm gonna be coding an implementation of it, so you can see what the code would look like. So yeah, HackerRank uses standard input, and then the first thing would be to read in the number of rows and columns. I'm actually gonna call them rows and columns instead of n and m, just to make it more clear what they mean. And then we would have the grid of numbers, which would have dimensions of rows by columns. And then we would go ahead and read in that the grid of numbers. So you would loop through all the rows, and then you would loop through all the columns. And then assign the current cell to like the current value in the grid. So that would read in the input. So now we're trying to we want to maintain the count of like the maximum sum we can get. So we're gonna have a variable called max sum that will initialize to 0, because that's like the minimum possible value, and then this will be what we print in the end. So now we're gonna loop through all the possible positions of the center of the 3 by 3 square. So we said that we would ignore anything on the edge, so we would start at row 1, right? You would start at row 1 instead of 0. You would skip row 0, and then you would also skip the last row. So you'd only go up to the second last index. and then you do the same thing for columns. So this considers all the interior cells as the center. And then for this given center, we want to find what the sum is. All right, so we'll call it curve sum. And then to actually compute the sum, we will, as I said, you would loop over all the delta r's. So basically how much the r, like the row, deviates from the center. So it can only deviate from -1 to 1. And then you also have to consider deviating for the column. And then curve sum would go up by grid of r plus dr and c plus dc. So like what this does is you can kind of visualize, like if when dr is -1, that would be like in, say, this 3 is the current center cell we're considering. Then when dr is -1, it would be looking at this row. And I'll loop through like dc being -1, 0, 1, and then move on to dr is 0, and then it would do the same thing going over these 3 columns. And then for dr equals 1, r plus dr would be this row, and then the dc would go over these 3 cells. So this after this nested loop, we have the correct count of the 9 squares in the current square. I mean the 9 cells in the current square, and then we just need to max our answer with the current answer, or like the current sum. So now at the end of this, the max sum will be the maximum sum of a 3×3 square. So we can just print that. Okay, let's run code to see if this works. Oh, we had to do math.max. Okay, so that worked on sample. So let's submit this. All right, and then it passed. So that means this is a working solution. So does anyone have questions about the solution or how I coded this? All right, so I think no one has questions, so I will let Andrew know.
All right.